Hi folks. Today we're looking at product and quotient rules for differentiation, and those should make us think of multiplication and division respectively. So one question that we might have is, like, if I had f of x is x plus 2 by x plus 3, would it be fair to say that the derivative is just derivative of x plus 2 times derivative of x plus 3, so derivative is just 1? And clearly that is false. Okay, because the slope of the parabola is not 1 everywhere. So if you have two things that are multiplied together, so product of two parts, that you could call them u and v if you wanted, the derivative is, so these are both, let's just write this. This is multiplication. When we say product of two parts. U and v are both functions of x. They include an x. They're not just coefficients. Have an x. Then the derivative is derivative of the first part, the u, times just the regular second, plus the first times the derivative of the second. Okay. Now, you can also write this in other forms. You could write it v u prime plus v prime u, or sometimes you'll see it this way, v u prime. Really sucks that these letters are so close together, hey? Sometimes this will call it 2d1 plus 1d2 for the second one. There are all sorts of ways to remember this. This is the way I learned it. In calculus was u prime v plus uv prime. Keeps it in the same order of first and second, and you start with the derivative of the first. So if I looked at this function that's down below, what I would say is it has a first part that's being multiplied by a whole second part. The first part in this is that root x, or x to the half. And the second part is everything else, including the power that goes with it. So 2x plus 1 to the power of 3. Those are the two things that are being multiplied together. And u prime is pretty easy to find. It's 1/2 x to the power goes down by 1. Because it's just a regular x, you don't have to worry about the chain rule. Though if you did, you'd just have a times 1 at the end. I'll write that negative 1/2 a little better. V prime. This one here, there is a chain rule at play, because it's not just x cubed, so it's a glob cubed. So you got to go 3 times that glob squared times the derivative of the glob, which would be the derivative of 2x plus 1 is just 2. So let me clean that up. That would be 6 times 2x plus 1 all squared. If we want to find the derivative function, it's really just plug and chug in this formula. So f prime of x is going to be u prime times v, which is 2x plus 1 all cubed, plus u, which is x to the half, times v prime. And there is not a lot of simplification that needs to happen here. Generally, for each term, we would like the coefficient to show up out front. Okay. And so in this one, I'd rather see the 6 in front of the x to the half. And you could factor this if you really wanted to. You could write these in radical form. You could make a common denominator and put them together. But at this point, we have something that is fine. Unless they ask for something fancier than this, we're okay. And we could sub values into this. Okay, maybe there's a simpler way to express it, but this is fine. Then it'll give us the slope anywhere. And yeah, it's a mess, but it does the job. So let's try another one. If we wanted to differentiate this whole thing, well, you just ask yourself, what two things are being multiplied together? If you see x's next to each other without a plus or a minus, chances are there's a product. And people miss the product rule all the time. The other way you can find it is by actually mumbling the question aloud to yourself. Y equals x squared times x squared. Oh my gosh, that's got to be a product, right? So x squared times bracket x squared minus 2x all to the 4. So the first part of this is x squared. Okay. The second part is all the rest. X squared minus 2x all to the 4. Okay. And finding u prime is no biggie. That's just 2x. Finding v prime is also no biggie. It's 4 glob to the 3 times the derivative. Okay. And so we can just plug and chug. The formula was u prime v plus uv prime. If you recognize the product rule, it's hard to botch it. Because as long as you do derivative of one times the other plus vice versa, then you're fine. So u prime v plus u v prime. There's no 3 there. Let's clean it up just a touch. 2x, x squared minus 2x plus 4x squared, x squared minus 2x cubed times 2x minus 2. A bit of a mess. Again, this is fine. If you really did want to clean it up, one of the easiest ways that you could do that is to take out a greatest common factor. So this happens to have a greatest common factor. There are only 2 terms. There's this one and this one. There's a 2 that's in common. And sorry, I missed the squared on this. That's not fine yet. There we go. Now it's fine. There's a common factor of 2, of x, and also of x squared minus 2x to the 3. That's a power that they all share at the very least. So you could do it like this. 2x, totally optional. Maybe I'm going to regret doing any of this. And so in that first portion, all I'd be left with is x squared minus 2x. Okay. In that second portion, you'd be left with, let's see, to take out 2x out of 4x squared, you're left with 2x. Okay. And simplify to taste. To taste. You could combine some terms inside those big blocky brackets. But again, this right here, I'm going to put it in green. This is absolutely fine. Let's use this to actually find a tangent slope, because you don't need the simplest form to be able to find a tangent slope. So we have y equals x4 times 3x minus 3 all to the half. I'm thinking of this as u is x to the 4, u prime is 4x3. No chain rule needed because it's just an x we're operating on. Okay. This part, the second half that I'm multiplying by is 3x minus 3 to the half. And this does need a chain rule because it's not just x. It's a glob that I'm raising to the power of a half. So that's negative a half times the derivative of the inner, which is 3. Or I could write this as 3 over 2, 3x minus 3 to the negative a half. Good grief. All right, let's go ahead and find this derivative function. U prime v plus u v prime. So that would be 3 over 2, 3x minus 3 to the negative a half. Right here, I could simplify this. I don't think it's worth it. I'm just going to sub in, because all I want in the end is the number for which this works. So it gives us a point. It gives us extra information. So at x equals 4, let's just put this in. This will be 4 times 4 cubed times, I'm just going to do this together, 3 times 4 minus 3. That would be 12 minus 3, or 9 to the half, plus 4 to the 4 times 3 over 2 And again, 3 times 4 minus 3 is 9 to the negative a half. Yeesh. So that's 4 times 64 times 3 plus 4 to the 4 is 256. These are probably bigger numbers than you would get necessarily on an IB paper 1. 3 over 2, and 9 to the negative a half means flip it and square root it, so that's 1 over 3. So that's 256 times 3, which would be 768, plus, what's this going to be? 256 times those 3's will cancel out, times a half. And not y, but y prime is 768 plus 128. I'm just stalling here to try and figure this out. I think that's 896. Okay, it's real steep there. You could take a look at that function. I bet you it will be, indeed, really steep there. So the next question is, what happens if you differentiate when you have division? So what if I had like x plus 1 all over x minus 3? Would it be okay to just say f prime is 1 over 1? And you can guess the answer is no, because that original function is not a linear. It's not going to have a slope of 1 everywhere. So now that we've done some products, it might cause us to investigate what happens if you have a quotient. We can actually prove it, though if you want to glaze over for these minute or so when we prove it, that's okay. What you really need is the result. So if I have f of x is something over something else, u over v, I can actually rewrite that as a multiplication. And I'll be honest, I forgot my quotient rule at my Calc 1 exam. I'm not proud of this, and so I did everything with product and kind of did it this way. So if I did derivatives here, it would be derivative of the first times the second plus the first times the derivative of the second. And this is kind of sneaky. That would give you negative 1, v to the negative 2, and because v is a function of x, from the chain rule, you'd have times its derivative. Okay, so times its glob. You didn't need that for the u because there was no power on it. So that would give me, this is u prime over v minus u v prime all over v squared. Okay. That's the formula for differentiating a quotient, but it's really ugly. It would be nice if it were over the same denominator, so let's just times this one by v. And so we get u prime v minus uv prime all over v squared, okay, where u is the function on top and v is the function on the bottom. That is the quotient rule. Sometimes people will write it this way, v u prime minus u v prime. I just can't handle it when it's not in alphabetical order. So people sometimes miss the product rule. People almost never miss the quotient rule. Right? So the quotient rule assumes that these are both functions of x, though it's okay to use it if they're not. It may just be a little heavy-handed. So if I had this one here, I'd be thinking u is my top, is 1 plus 3x. Which means that u prime is 3. V is my bottom, is x squared plus 1, which means that v prime is 2x. And if I want my derivative, I just plug and chug. U prime, 3, times v, x squared plus 1, minus u, 1 plus 3x, times v prime, that's 2x, all over v squared. Unless it's a monomial, there's almost never any point in expanding the bottom. Okay, so we've got our derivative now. We can make it look a little nicer. If you actually write out these u's and v's like I did over here and here, then these are going to be a breeze. You just need to write them in and plug them in. On top, I can multiply out. That'll give me 3x squared plus 3. Here, be really careful. We're still subtracting this whole thing, so I'd be inclined to do my multiplication and keep it in brackets until I'm quite sure that I'm not going to screw it up. Okay, so h prime of x is going to be 3x squared plus 3 minus 2x minus 6x squared all over x squared plus 1 all squared. and that top can simplify. If all you needed to do was throw in a number, well, I think you could throw it in at any point. So we have negative 3x squared minus 2x plus 3 up top. If we could factor it, we might, for the sake of being able to simplify. Doesn't look like it's going to help, though. Let's do two more with the quotient rule. So in this one, u is 3x. That means u prime is 3. V is the whole bottom. And you might notice here that the bottom is a glob. So V equals this. That means V prime is going to be 3 by 2x cubed minus 1 all squared by the derivative of the inner, which would be 6x squared. So V prime, we could write it like this: 18x squared, 2x cubed minus 1 all squared. And it's probably worth taking the time to simplify that out. So now we're going to go, all right, we know it's u prime. I'm going to write it out here. Is u prime v minus u v prime all over v squared. People forget the bottom all the time. It's a quotient. It's got a bottom. So 3 times v minus u times v prime. All over v squared. So that's 2x cubed minus 1 all squared. All cubed, rather, all squared again. One thing that you might notice here is that you're going to have some common factors. Okay, so I notice on top that I'm going to have a common factor of 3. And I'm also going to have some of these ones. I got 2x cubed minus 1 at least to the power of 2. So I'm going to pull out that greatest common factor, 3 times 2x cubed minus 1 all squared, because it will let me simplify the fraction. Again, if it doesn't care for anything simplified, you can leave it in as ugly form as you like. Let's go through the process. What's that going to leave us? Well, in this first term, it's just going to leave us with 2x cubed minus 1. Okay. In the other term, it's going to leave us with the 3 will be gone here, but you'll still have an x times an 18x squared. And this will be all over 2x cubed minus 1 all to the 6. And the reason that we want to factor is that at this point you can divide some of these out, so that in your next step you'll have something that hopefully looks a little nicer. You'll have 3 by 2x cubed minus 1 minus 18x cubed all over 2x cubed minus 1 to the 4. And sometimes we're going to differentiate again. We're going to find a second derivative. And having a simpler form is going to make that easier. Or 3 by, let's see, negative 16x cubed minus 1 all over 2x cubed minus 1 to the 4. Okay. A lot of places you can make little goofs here. But in the end, whether you write it sort of in this form or in this final form, that should be all right. If you really want to, you could factor out that negative as well and write it like this: 16x cubed plus 1. Yet another way. Okay. But unless otherwise stipulated, it doesn't matter what form you leave it in. Okay, one last one. We're going to do this one where u is x to the half. So u prime is going to be 1/2 x to the negative a half. And the bottom we've got v is 1 minus 2x all squared. So v prime is going to be 2 by 1 minus 2x to the 1 times negative 2. Or you could call it negative 4 1 minus 2x. So if we find dy by dx, well, that's u prime v, so that's 1 minus 2x all squared, minus u times v prime, which would be, I don't write v prime, I write negative 4 by 1 minus 2x. And that'll be all over 1 minus 2x all squared. And that's pretty good. I mean, I can rewrite it this way, 1/2 x to the minus a half. And this will be plus 4x to the half. Okay, and that'll be 1 minus 2x. And sorry, on the bottom that should have been squared squared. And not squared here. Yeesh. A lot of little spots for mistakes. And so on the bottom we have 1 minus 2x all to the 4. The only thing you would get in trouble with here from the IB is the fact that you have a nested fraction. So the easiest way to deal with that is just to times the top and bottom here by 2. That's one way around nested fractions. So if you do this whole term by 2, then the half goes away, and you just have x to the negative a half, 1 minus 2x all squared. And then in the other one, you'll have to times this whole thing by 2, so that'll give you 8x to the half, 1 minus 2x. And on the bottom, you'd have 2, 1 minus 2x, all to the 4. That is plenty for doing this one. If you want to go further, you can. But here are some practice questions on page 238, 239, and 240, where you're just plugging, chugging with the product and quotient rules. I honestly think they're probably a little less rough than the examples that I've given here. If you want to go further with simplifying this, there are a few things you can do. I hate those powers of half, so I could times the top and bottom by a power of x to the power of a half. And that's going to make this turn into an x to the 0, so it'll just go away. That'll be real nice. And it'll make this one turn into an x to the power of 1. And on the bottom, you'll have x to the half, which is root x. 1 minus 2x to the 4. If you want to go even further with it, I applaud your tenacity. There is a common factor of 1 minus 2x, and that would leave us with 1 minus 2x plus x, okay, all over 2 root x, 1 minus 2x to the 4. And you could do a little bit of reduction here. These would go away. So in probably close to simplest form, or a very simple form, it would be 1 minus x all over 2 root x, 1 minus 2x to the 3. Okay, because this would have gone to a power of 3. Again, that's pretty nitpicky. Hopefully this stuff has been helpful. The main thing to know is those two rules, namely that uv turns into u prime v plus uv prime, and uv turns into u prime v minus uv prime all over v squared. Hope this has been helpful. Good luck with the material, folks, and take care.